All right. So it's a very special pleasure to welcome Walter Kohn as today's Colloquium speaker. And, well, I'm sure Walter does not need any elaborate introduction to this audience gathered in Kohn Hall. But let me just briefly say that the topic of today's Colloquium is not directly part of Walter's research specialty, namely theoretical physics, theoretical chemistry, and condensed matter physics, which he is so well known for. Today's Colloquium is on topics Walter has been dedicated to in the last decade or so. These are the topics of solar and wind energy. So part of Walter's activity in this area is his membership of the Science Advisory Committee of the U.S. Department of Energy under the Bush administration. Also, since last year, he's a member of the advisory board that will look at the basic research done at the Natural Renewable Energy Laboratory in Colorado. Moreover, also, as many of us here know, he has been traveling all over the world with the documentary film The Power of the Sun that he made jointly with Anne Heger. That film has been translated into many languages, including Spanish, French, German, Italian, Chinese, Arabic, Hebrew, Urdu, Filipino, and Serbian. Now, maybe I see some members here in the audience that are not necessarily from physics, and Walter has specifically invited people from other departments. So for those members from other departments, let me just mention briefly that Walter came to UCSB in 1979 as the founding director of the ITP, now called KITP, which under his leadership rapidly developed into one of the leading research centers in theoretical physics worldwide. Before coming to UCSB, he was a professor and chairman of the UC San Diego Department of Physics and professor in the physics department at Carnegie Mellon. Before that time, he worked at AT&T Bell Laboratories with William Shockley, the leader of the group that invented the transistor. So, of course, anybody working in condensed matter physics knows Walter's innumerable and seminal contributions to the field. And it was then in 1998 that he was awarded the Nobel Prize in Chemistry. So let us begin today's colloquium, a world powered predominantly by solar and wind energy. Walter.
You've seen the title, one word, which we need to keep in mind all the time, namely world. This is a worldwide issue. You can look at it in two ways. You can look at it as a worldwide danger. You can also look at it, and I think one should look at it both ways, as a wonderful opportunity for global cooperation. The carbon dioxide that we put up in the atmosphere, wherever it is, pretty soon spreads all over the world, and it unifies us. And that's one aspect of the worldwide nature of the subject. The other aspect is, not unrelated, that there is a wonderful degree of worldwide collaboration. Everybody here, I suppose, has read at least a little bit, maybe much, about this last Stockholm meeting that had people from all over the world coming. And it was very fortunate that our still new president was able to hold it together at the last moment. It was quite dramatic because this is a worldwide problem, but the world population is not uniform. There were great tensions there, loosely speaking, between the highly developed world and the less developed world. And the president has had a lot of things to do at home. He arrived there at the last moment. He found quite a number of members already at the airport, ready to leave. And he managed finally to just get something together, which held this, maintained this global collaboration. As part of that, as has already been mentioned, I do quite a bit of traveling. And I want to tell you that this, you may wonder why is this videotaped. I was invited to participate in the 50th anniversary of the Kanpur Institute of Indian Technology. It's one of about a dozen, I think. I also think it was the first one. And they're 50 years old, so they were planning a celebration. And they'd heard that I'm now working in this area, and they wanted me to come there. I had just been in India, and I'll show you a picture of that to convince you. And, you know, it's from Santa Barbara. India's a big country, 24 hours each way. And to do that again 2 months later, I thought, I have to get around that. And so I told them that we're doing this colloquium here, and I'll try and have it videotaped, and including a discussion, including you people, to behave well. And then we will, when my time slot comes over there, they'll show the video, and when the discussion comes, they'll first see the discussion here, and then I'll be connected by, you know, whatever, telephone, video, and so on, and I will do my end of the discussion from here. Okay, so first one, that's India. It's a very interesting college near Madras. Everybody's heard of Madras, but maybe not yet of Chennai. Chennai is the new name of Madras. And this is after I showed the film, The Power of the Sun, and there was a fantastic discussion with those students. It was really incredible. Interesting college, by the way. Built by a very successful computer person who made $1 billion and built this college, and it is especially for the best students that cannot, for financial reasons, attend the university. I could tell that they were the best students. They were a wonderful bunch. Okay, so it's the global aspect of the issue that why I put this as the first global cooperative aspect, why I put this as the first slide. Okay, next one. That's also India. And that, a large fraction of the world's population that has visited that thinks this is the world's most beautiful building. This is the Taj Mahal. And so I got a little reward for these 48 hours of travel and had a chance to see the Taj Mahal. I also, while I was in India, I had a chance to have quite substantive discussions with the deputy chair of the Indian 5-year Planning Commission. And I was very happy to hear that India, which, well, as late as 5 years ago, I would say, was still close to 100% committed to nuclear energy, has now shifted their emphasis. Of course, they have a huge investment, intellectual and other material investment in nuclear energy, and they are not dropping it. But they are shifting towards primarily solar energy and wind energy, and they were interested in my perspective on this and what's happening in the United States. So I'll say it right away. I had intended it for the end. But just yesterday, I picked up the latest report on what has happened to wind power in the United States during the 2009. So they have the numbers in. And it has, in this 1 year, it has increased by 40%. So it's a remarkable development. Is this the one swallow that does not make a spring? No, there are at least 5 or 6 swallows, because it has been growing by, if not 40%, 30 or 35% over the last, every year over the last 5 years. So that shows you things are happening. Are you surprised that that much money was put into wind energy just last year, where we are still struggling with the global economic crisis? And I read in this article that the people in the industry were very worried that there wouldn't be any money available. People, as you know, couldn't find money for any investments, or it's very hard to find money. But this is mostly stimulus money. And that's a good way of spending it. Okay, can I have the next one? All right, so just for people, and there must be many people here who really are not broadly oriented about this general subject. So I'm starting here. This is an old slide, but I did check it. I didn't find another one with this useful pie chart design, but I checked the numbers. The numbers are a little different, but not by more than 2 or 3% between 2001 and the present time. So don't worry about that. You'll see sometimes in thinking about such problems, the same physicists that in some other context will spend 10 years to get the next decimal point, here factors of 2 will have to do. So notice number 1 is oil. So we are coming to the end of an age of oil, to simplify somewhat. Then you have coal and gas, approximately the same. And there are, of course, many other forms of energy, and you've heard of them, nuclear energy, etc. They're lumped in this other category. Let me, since I have this here, let me take the opportunity and explain that I will not, and the title already bears that out, I will not talk about coal. Coal, first of all, is very abundant, and it is currently very widely used, 23%. Everybody here must have seen pictures of Beijing before the Olympics and become aware that the government, prohibited cars. Cars, I think, were allowed to drive only every other day. It took enormous measures so as to make those Olympic Games possible because of pollution produced by coal. And this is very serious pollution, causes enormous lung and other problems. Secondly, coal is just about the best, in quotation marks, greenhouse gas. When you burn coal, you produce carbon dioxide. Carbon dioxide is the main greenhouse gas. It goes up there and stays there for hundreds of years. So I was glad to see when I looked at these charts that, in fact, if you take oil and gas together, you come to a much larger figure than coal itself. China is one of the big burners of coal, and that's another story for another seminar. So that's the situation. This other nuclear, I pick out nuclear, total fraction on this pie chart is only a few percent. One hears, and quite properly, of the tremendous success that the French have had with nuclear energy in producing electricity. They produce, as far as I know, 100% of their electricity now with nuclear energy. If not 100%, very close to it. The reason that it doesn't appear on this chart is it is neither a substantial part of the total energy production, nor is it rapidly growing. That's part of the reason. The other reason, which I consider to be more serious, by the way, my original academic background is in nuclear physics. We have seen in the last 5 or 10 years the tremendous danger of proliferation and the threat of proliferation, nuclear proliferation. So the worst offenders have been, well, as individuals, perhaps this Pakistani head of the their Atomic Energy Commission, who sold information and material to North Korea, and continues to be, incidentally, admired as perhaps the greatest national hero. He's under house arrest. Way back, Gaddafi was threatening with his nuclear program. Totally unpredictable person. At a certain time, he said, "Okay, I'm just giving up entirely our nuclear stuff." Thank God. Iran, you hear it all the time, right? You hear two things side by side, that Israel has no right to exist and will be eventually wiped off the face of the earth. And incidentally, we, the Iranians, are not building any nuclear weapons, but we're building a general nuclear infrastructure. And everybody in the business knows that the time to produce nuclear weapons starting from a good nuclear infrastructure is about 5 years. So you don't find nuclear here. Nevertheless, I took the opportunity to tell you my biases about nuclear. Okay, let's go to the next one. So this is another picture of world oil production, and I think it looks as though it should be well visible from the back. Is it? Can you read it? Okay. So see that big, more or less dark blue at the bottom. That's the oil that was produced from currently producing fields. So it goes up, and then around now, that starts coming down. Those fields that until the present time have produced most of the oil, by the time we go 20 years further, it's going to be down by a factor of 1.5 or 2. So they are evidently being exhausted. Then known crude oil fields, and once a major field is discovered, it is explored very energetically, and there are reasonably good estimates of how much eventually it will produce. So you can see that this next category, the light blue, is quite substantial. We know they exist, and we know they also will gradually be disappearing. Beyond that, you go into speculation. Obviously, oil has been such a valuable resource that an enormous amount of exploration has already taken place. So one would be very, very unreasonable to expect great surprises from oil fields that we have never yet seen. So everything else is smaller, and without spending too much time on the rest of it, I just want to point out, when you add it all up, you notice that oil production is estimated, total oil production is estimated to continue to increase for another 20 years. So, if you're my age, you would say, it's not my problem. But when you look at the next slide, you will see that it's even my problem. Please. Oh, excuse me. This is something I forgot about, but very important. Spend a few minutes on that. World population. Well, just to get an overall picture, we are now in 2010. Look at 50 years ago, 1960, and we have 3 billion. In 50 years, 2010, we have almost 7 billion. So in 50 years, it's grown by more than a factor of 2. And by the way, the previous 50 years, it also grew by a factor of 2. Very alarming. Very alarming. Very little in the public discourse. That's, again, another seminar. But I do want to say, because this is largely a young crowd, as you'll see in the next slide, the continuing increase of the world population is a major factor in our energy and global warming crisis. It's also a major factor for many other purposes. I'm sure there are some people here from the life sciences, and they know that we have a disastrous loss of species just due to the fact that with the population doubling, quadrupling, octupling, the human footprint is just becoming so large that it destroys the kind of environment that many species require in order to continue. So we've had a totally unprecedented rate of losing animal species. Another very serious consequence of continuing population growth. Okay, this is a famous cartoon. Many of you haven't seen it because it's very old. It's 1971, Pogo, but everybody's heard the name Pogo. Pogo stick, at least. But here Pogo is speaking. You see there's a kind of beautiful landscape on top, and now you see there's all this junk, garbage, and so on. One of them is complaining, it isn't beautiful anymore, it's actually quite hard to walk on this stuff. And Pogo, in a very thoughtful mood there in the lower right-hand corner, says, aha, we have met the enemy and he is us. Who is responsible for this growth of population, right? I mean, this is one by one, a man and a woman. And in connection with my topic, let me say, the most cost-efficient way, it not only doesn't cost anything, it does some good things, is to stabilize world population. And most people here can do something about that. How do you stabilize the world population? Not by, really totally unacceptable, undemocratic ways. The best way, good statistics exist on it, and it's very effective, is to bring the educational level, globally, of women to the same level as men. The rest takes care of itself. Here, I think at UCSB, I don't know the statistics, but I see more females than males, so you're doing all right in that respect. And so I assume that you're not contributing to the population explosion. But as you know, right, you read about the Taliban, women in Afghanistan and so on. Education, women's education, that's a side remark. But this is a wonderful opportunity for me to express all my personal views. Okay, next please. Okay. This has very much to do with the previous slide. And if you don't read this carefully, you'll say, how this is about global oil production, but it says per person. And you notice that global oil production overall, not per person, increases, remember from the last thing, beyond 2000, I forget what the last time was, 2040 or so. But global oil production per person, that stops in about 5 years and then goes down. And why does it go down? Because the very slow increase in oil production just doesn't keep up with the increase in population. So this dramatic change of the peak, depending on how you define it, peak oil production overall or oil production per person, that's due to that increasing growth of population. Next, please. Okay, so I think, turn that off for a moment, please. Now here are some broad principles for dealing with the global challenges of energy supply and climate change. It's very pressing, right? That peak is right there. It requires strong global cooperation, or we are not going to get together. World population can be stabilized by the middle of the century. That's a realistic target. America is the biggest per capita consumer of energy and of global warming production per capita. That has to be rectified. Renewable and benign energy sources, of which, in my view, solar and wind are the leading ones, must be substantially enhanced. Well, it happened already last year. Let's keep going. Okay. A question is often asked, well, two questions. Biofuels. Biofuels are, from the standpoint of energy and global warming, very acceptable. They are not acceptable, or not generally acceptable, when you include the fact that another problem that we have, and that's a global water shortage. But the biofuels, of course, compete with water. Another thing that I was already asked about this morning before this talk by a student who came in, nuclear fusion. So when we speak of nuclear energy today, this is always nuclear fission. a nucleus is split, an appropriate nucleus like uranium or plutonium is split in two, and in that process, the two halves, and usually also some neutrons that come out, have acquire an enormous amount of kinetic energy, which can be converted into heat and drive heat engines. Nuclear fusion is kind of the opposite. It applies to different nuclei, to very light nuclei, which when they collide can and do sometimes fuse together to produce a larger nucleus, and that also produces energy. Nuclear fusion is now an international project. It's been, I guess, running for about 10 years. And this is a process that is very well established and studied and understood in a small laboratory setting involving a small number of nuclei and irrelevant for nuclear energy production. But it is now being studied on a large scale, and there's an international project that goes by the acronym ITER, in which both the Soviet Union and we and many other developed countries are participating. I know one of the more senior people involved in this, and his take is that if it is successful, commercialization might begin in about 100 years, and the chance of this happening is on the order of 50-50. Not something we should count on. So, let's see the next. Let's see, yes. Are you now able to control the on and off switch? Okay, so now we'll do a little mathematics at the level of freshman mathematics. This is a kind of a quantitative, very simple representation of a transition that I foresee and hope for from the two major sources of energy at the present time, oil and natural gas, to what I hope will be the two major sources of energy in the next era. In the next era, I'll explain that with this graph, I estimate, with caveats, which I will describe, to the transition will take place in 2021. Now, it's always ridiculous in science. That's going to have such a large degree of uncertainty and so on to give a date like that. But I simply did the mathematics, and that's how it came out. Of course, I don't believe it to that accuracy. But it does convey something to you. It is not likely to be in this decade, and it is likely to be sooner than in 3 decades. And that gives you some orientation. This mathematics gives the result 2021. What is the mathematics? What's the input? The main input is the fact that I've already mentioned in conjunction with the wind situation, that I think now I can say over the last 5 years, the annual increase in both solar and wind generation has been about 35 or 40%. So I've taken one of these numbers. I think finally I took 35%, which, as I told you, was exceeded by wind energy, at least in the United States. That is the crucial input. And now I have to confess to you very clearly how I handle this input. My assumption is, I'm trying to gaze into the future, my assumption is that this rate of growth will continue at that level. I do not assume any breakthroughs, technological breakthroughs. I hope they will occur. I use in these estimations the current technologies, and I've asked myself, is there a reason why this fractional rate of growth of 35 or 40% per year cannot go on for a very long time, so in which case this would be ridiculous, for example. But we know solar energy will not be exhausted, unlike other sources of energy. We know wind energy will not be exhausted. We know that the materials that are necessary to build these installations for solar or wind energy are essentially inexhaustible. For solar energy, the most important ingredient is steel. For solar energy, the most important ingredient is silicon, which represents a large fraction of ordinary sand. So, inexhaustible sources. There's another question that I ask myself, and I have very little competence in dealing with it. Nevertheless, I took a shot at it. And that is, well, where does the manpower come from? Can you imagine in something on the order of 10 years to replace the entire conventional power station infrastructure by a new infrastructure that consists of solar cells or solar installations, wind turbines? Can that be done? My conclusion was that it will make enormous demands on our economy. There won't be any unemployment. But that it does not require, let me put it this way, it will require, in my very rough estimation, 3 times as much manpower as goes now into the production of energy. Very serious, but not a showstopper. So, on that basis, I've drawn this diagram. Start with the purple, slightly downward sloping line. That's oil and natural gas. It's a projection, and I'm taking a kind of roughly the average of the real experts in this business who say it's going to, once it passes its peak, it will decrease by about 2% per year. So it's a very gently sloping downward line. And even if that's somewhat wrong, if it isn't 2% or 4%, it's not going to change the overall picture. The much less certain input is this combination of solar and wind, where I've used, as I've told you, this 35% annual increase. I didn't see a showstopper, but certainly it's going to be a major weight on the economy. And there you see that beyond 2021, solar and wind produce more energy than oil and gas. So I think if this does happen, it would be just a huge revolution. And this is a good revolution because it takes place without coal, which damages, which is polluting on Earth and is polluting in the atmosphere. And it doesn't use nuclear, about which I've spoken before. Now, Next one, Patricia. I want to show you what is happening in solar energy now. I want to show you what's happening in wind energy now. And you'll see there are some other very promising things. So this is the Moscone Center in San Francisco. I think it was the first municipal building in California, at least. These are conventional solar cells. I have similar solar cells on my roof. If you want to know what it cost me, and I hope that will be of interest to you, it cost me $17,000 to install, and my electricity bill is close to zero now. They will last, they're guaranteed to last 25 years. These residential solar installations are becoming more and more popular. California is a leader. Not the leader, but a leader. Okay, next please. Yes, this is something I just picked up on the web, I think yesterday or the day before. And it's an amazing thing. This is the initiative of the European Union to use the Sahara Desert, including its coastline, for solar and wind generation and other purposes that I'll mention in a moment, to be used in Africa, but primarily in Europe. Now, where's that baby? All right. First of all, to understand what these symbols mean, these are concentrating solar power stations. They are not photovoltaics. These are large power stations like you see ordinary coal-fired power stations, not like what I have on my roof, which are something like 10 cells of model size. Then these are photovoltaics, and you see here and there are quite a few of those. The blue babies are wind installations, wind parks, hydro, very minor compared to the rest, but nevertheless, here, biomass, and geothermal. But in this talk, we concentrate on solar and wind. Those are the first three, and they are, in fact, the most important. Notice the wind installations, the blue ones, tend to be primarily along the coastline where the winds are strongest. And, of course, they are here, these are other coastlines. And some of you may know that, very interestingly, the country that has made the biggest progress using wind turbines to generate electricity is Denmark. And they have a plan, they have a timetable, they are sticking to it. And I think in about 20 years, they expect to get all their electricity from wind power. You see, there are connections, incredibly long connections, crisscrossing parts of Africa, and crisscrossing a large fraction of at least Western Europe. The European community has agreed to carry this out quite recently. If my memory is correct, and if somebody finds it's incorrect, please correct me, I think it is $550 billion. I've never done the arithmetic on the war in Iraq, but it's probably comparable. So I'm an ex-European, and when I see something like this, I say, well, after all, I'm still proud of Europe. This is really something, to get this conglomerate of countries, you know, very, very different countries, to agree on this. We can't agree in Congress on the smallest detail of a bill between Republicans and Democrats, including bills that deal with energy. But here they got it together. And incidentally, one of the people who was, this is not, by the way, it's not non-controversial in Europe, but for the good of the whole, they adopted it. The technical work, preparatory technical work, and I'll show you some examples, has been going on for quite a while. Okay, next one, please. So these are some different ways of converting solar energy into electricity. There are reflecting mirrors here that concentrate the sunlight and can produce onto some working liquid that can be water, that can be certain salts that are demonstrated to be very effective in heat engines. These kinds of solar devices that concentrate solar energy on a working liquid and then use that in a conventional heat engine to produce electricity. These are very likely going to be used in large installations in Arizona. The one matter that I've read is that the Arizona installation will be about one-eighth of this European installation. Okay, next please. Okay, this is another geometry. Here you see a so-called solar tower. These are concentrating mirrors that focus the sunlight. They are moving during the day so that this point on which they're focusing remains unchanged. And here, one way of dealing with it is through photovoltaics, without the working liquid. Here you see what I think are tanks for purifying and desalting water, salt water, and using it for agriculture. So these installations, because of these desalination tanks, also can make major contributions to the local agriculture Next. Here, this is a wind farm in West Texas. I picked Texas because they are the leading state in wind production. Do you have any more? That's it. Okay. Now, we'll have discussion, but not quite yet, because I know from experience, if anybody gives a talk like this, students ask themselves, or they should ask themselves, usually do, so what does that mean for me? What can I do about this? Or what's the relevance to me? And I brought a gentleman here, my friend, Bruce. Where is he? Ah, there, right. He is the co-chair of the campus sustainability committee. Mostly students, but also a few staff members and also a few old guys like me. And he'll tell you in 5 minutes what that remarkable group has already accomplished and what they're working on now. Okay, Bruce, please.
Thank you, Professor Kohn. Just briefly, this campus has long been a hotbed of individuals interested in the environment, starting off with the oil spill many years ago. And I think we all realize that the world Professor Kohn is talking about, yes, is made up of a huge number of other individuals, but it starts with us. That oil spill generated an energy on this campus, which started off, of course, with environmentalism, but through many years has been quietly building into the areas of sustainability, including the energy use that Walter has just talked about. And I would say starting in the 1990s, a substantial number of staff members began to work quietly simply to build towards what was not even then referred to as sustainability, looking at ways of conserving energy, of using the Earth's resources more wisely. In 2005, those individuals came together for a meeting, and it turned out there were about 70 individuals, staff, faculty, and students, to begin to plan a more organized mechanism by which this campus could address sustainability. That led in 2007 to a campus sustainability plan, including energy reduction, which was paralleled by other motions that were underway at UC-wide. In 2008, the plan mandated, and there was established, a Chancellor's Sustainability Committee, which is the group to which Walter refers, and I co-chair, and he is a member. That group includes 20 faculty, staff, and students who are working together as a group of dedicated individuals who are interested in what we can do to make UCSB a better place, both in terms of the function of the institution and its energy use, its material usage, and the education it gives its students. So there are actually two committees. There's the Chancellor's Sustainability Committee, and then there is an Academic Senate Sustainability Working Group, which is focusing upon aspects of education, aspects of making certain that the kinds of expertise that are on campus are spread to our students and beyond the community. Our charge is to advise the higher administration, but what that means is finding the intellectual resources and harnessing them to address the problems that are out there. Some of those are small problems. Something that you may find a bit amusing, but which is true, is we finally, in the next month or so, are going to have a sustained, as it were, a consistent recycling policy on campus, rather than the great diversity of containers you have seen in a wide range of buildings, depending on who's in charge of it. That's minor. Major are things like trying to make the campus energy neutral. The agreement at the system-wide level is that by 2045, 95% of our energy will be via renewable sources. UCSB would like to beat that and beat all the other campuses in that direction. We'll do that both by individual changes in behavior, because the quantity of lights that are left on in a room, that's behavioral, that's something individuals can deal with. We'll deal with it by questions perhaps debating, well actually not perhaps, debating the relative merits of photovoltaic systems here versus some remote source versus perhaps a wind farm that is specific to UCSB. All of this calls upon the energies of everybody on campus. It calls upon the ideas and intellects. The members who form this committee are, in a sense, an extension of the campus as a whole. And one of the things that I call upon all of you in this room, having been exhorted by Walter, is that if you have ideas of ways we could better operate on campus, or if you have thoughts of ways that we can improve energy usage, or anything else, this committee exists as a funnel through which those kinds of ideas pass. Thank you.
I want to add just one thing that I was enormously impressed by. There is a relatively new athletic building. Students thought about that. It was not yet built at the time, or it was, excuse me, it was built at the time, but the roof was not yet used in any way, and they used their own funds that was passed by the student legislature to put solar panels on it. And most people are blown away when I tell them what those solar panels cost that were covered by student funds. $500,000. And it's a beautiful solar panel roof. Okay. Thank you, Bruce. And now discussion. And I remind you that this is going to be shown, including your contributions, far away near the Himalayas, and will begin over there in a couple of weeks a discussion and question and answer period in which I'll be here on the part of those students. Okay, so Andreas, would you like to handle the discussion?
You showed that very arresting plot of the oil production per person globally, but those were two global quantities which are not distributed uniformly in the same way. Is there much to be learned by actually doing that same comparison on a country-by-country basis? I mean, you could imagine that some country will actually experience that particular turnover earlier than others.
Yes. First of all, your first remark is absolutely correct and very important. The variations country by country are very huge. Can this be done country by country? Not in a meaningful way, because energy is movable. You know, the energy, you can't really meaningfully speak of the energy actually produced in a country. That depends, and my own study on which this talk was based was entirely global, but very much aware that there are totally different circumstances, totally different from the average in the very rich countries and particularly in the very poor countries.
Yeah. You said that you don't see any resource limitation. You said that you don't see any resource limitation preventing this rapid expansion of power. There have been reports recently that rare earth minerals used to make magnets for wind power are in short supply. Do you have any comment on that?
I have not heard it, and I have no comment.
You talked about the population pressures, but another large effect is, of course, the demand by less developed countries to achieve standards of living more comparable to the developed world. And I've heard some people, I guess in Steve Koonen's talk the other day, suggest that that's an even larger impact on the availability of energy for the world in the future. Can you comment on that?
Yes, I agree completely with that, and it was just my forgetfulness that I didn't mention it. I even have some rough figures on this. First, back for a moment to the population growth itself, but differentiating it or disaggregating it. Almost all of that population growth will take place in not very highly developed countries, in the very poor countries, in intermediate countries like China, no, not China, excuse me, India. But the per capita consumption in these countries the per capita consumption of energy in the highly developed world is rather stable, has been rather stable. But in the rest of the world, it is growing, and it is, for many people in the rest of the world, it is their main aim in life, to get to a level such as the developed world now enjoys. So I roughly estimate that by the middle of the century, very rough figures, we're going to go from 7 billion total population to about 9 or 10, I hope 9. And almost all of that will take place in the less developed world, where the population will double in that part of the world. The consumption in that part of the world will roughly, by my estimates, triple or quadruple. So thank you for your comment. There's a question in the back.
We have a question already here. So I have a question on the realisticity of having a world predominantly powered by wind and solar power. Because, as you know, the electric grid has to be very stable, has to have a frequency which has to be constant on time, and wind and solar power are varying over time pretty well on a day-to-day basis. And there is a maximal percentage of the power that can be provided by wind and solar because of that constraint of having a constant frequency. So do you know what is this percentage and how it affects your the ability of having a majority of power supplied by wind and solar power?
Mm-hmm. Very good point. Both solar and wind power are variable in time and on different time scales. Sunshine, there's less sunshine in the winter than in the summer. There is definitely less sunshine at night. And what does one do about that? Well, that is a major challenge. In part, without leaving the remarks that I made, you could see that the wind and solar power installations are interspersed there in the Sahara, for example. And nighttime there's no sunlight, but there is wind. So to some extent, the magnitude of the problem that you mentioned by proper layouts, designs, can be reduced by perhaps a factor of 2. Number 2, so in my house, I mean, I also want electricity at night, and since we have other sources of electricity in California, I borrow them from the grid and I give them back during the daytime. And in California, the electric consumption is mostly air conditioning, and so that's how that's taken care of. So I have no problem at all, as long as there's part of something else. So in order, and lastly, I'm not promising that problem will be completely solved, but an old-fashioned way of dealing with it are candles. Okay.
Yesterday's New York Times featured an article about China leapfrogging the U.S. as far as a maker of solar and wind technology. What are your thoughts, looking at your curve and the increase? What's the probability that we're going to be making this equipment and that the jobs that you mentioned that will come will be available for the United States?
Well, of course, this big uptick in wind turbines created new jobs. And the role of China, in my view, is, in the first instance, a global view, is a wonderful thing. I mean, they have increased their solar cell production so that within 5 years, they became the #1 country in the production of solar cells. So this is astonishing. Wind, similar situation. I don't know the number there. Is this going to... Now, your question, let me check that I've really understood it. Are you asking whether this will produce new opportunities for employment in the United States? Are we going to make solar cells for China, for example? No. For the United States? Oh, without question. Without question.
How about coal? So you did take coal out of your equation, but considering that it's
Excuse
a cheap...
me, where's the speaker?
Here.
Yes, thank you.
Considering that most of the energy consumption will be in the developing world, or most of the growth of it, so is not coal the dominant energy source of the future? Unless we have some global agreement worldwide on greenhouse gases or so.
Yes, that's a very important question. And 10 years ago, I probably would have said yes. But now, China is the world's most populous country. Let's think about China for a moment. Well, if you do any business in China, you have to go through Beijing. It's oversimplification, but in any case, it's an educational experience, because the unhealthy pollution, as global warming is an international thing, but the unhealthy pollution in Beijing is just something terrible. And I have noticed a growing awareness of this. They will use coal because they are still primarily committed to growth, not population growth. They were the first to have almost stopped it decades ago, but production growth. And they will use coal, and that was sort of out of my equation, as you observed. What I was saying, I was concentrating on the switch of gas plus oil, from gas plus oil to solar and wind. The role that coal will play, this is an important political issue that I think it's too late for me to try and get into. But thank you for pointing it out.
Coal can be used in principle if you can clean the pollution and the production when you use it, or to use the ionosphere if that's viable.
Or what?
Clean the gases, the greenhouse gases on the ionosphere. Is it viable option here?
Not at this time. It is also expensive. I mean, now the seductive character of coal is primarily that it's cheap. Everything else is not very attractive. But once you have to sequester it or use other means, you see all kinds of ads if you watch television about clean coal. Clean coal, this is like the dodo. It does not exist, right? So I don't want to rule out, for example, sequestration is that famous word, which has a nice rhythm. Carbon capture is a more prosaic expression for the same thing. We know what it costs today. Absolutely, it's another universe. Maybe that can be made possible. I don't know. As I said, I left such future technologies out of my equation, because that makes the whole subject much more woolly. Oh, excuse me.
Yeah.
I'm blinded by the light above you.
So I'm the token labor economist here, and I'm wondering what kinds of educational and training investments we'll need to make to prepare the workforce to install and maintain solar systems.
Okay. I don't think that's a huge hurdle. I mean, these are sort of the same training that a regular electrician gets. It's not, of course, if it's on a very large scale, it is important, but it's not a sophisticated training.
I saw a couple of talks about thorium-based fission reactors, and I guess the claim was made that the byproducts that you get from that reaction, you don't have the same sort of waste and proliferation issues. I was wondering what your opinion is on that.
Yes, that proposal is now probably between 10 and 20 years old. I followed it at the beginning, but I noticed that nobody invested in it. And precisely what the economics of this is, I can't tell you.
Okay, let's have one more question. There was one in the back, and I think we have to wrap up slowly. Give it time.
So your talk has focused on solving the problem of the energy crisis through increasing the supply. You did not have much chance to talk about reducing the demand through increases in efficiency. Was that a statement that you think reducing the demand is less effective, or did you just not have time, or what?
I forgot it. I had it in my notes. Very important. Very important. So for us, Americans, let's just look over at Europe. You travel in Europe to feel that you're traveling in a backward area or in a poverty-stricken area. No, they just don't waste that much energy as we do. Now we have on this campus, we have a new institute, I don't see Mike Bowers here, that is called Institute for Energy Efficiency. That's something slightly different. But what it is it doesn't lead to lower energy consumption, but to energy sources that require less energy. Of course, the spectacular thing are these new contemporary LED lights, one of which I carry in my pocket always. I've had it there for 6 years. It's doing fine. It's very good for reading theater programs. Here it is, by the way. Let's see if you can see that. Yes, thank you. You're absolutely right. conservation and energy efficiency are a very important part of that whole equation.
Okay, I guess let us end. Let us end the colloquium by thanking Walter and also Bruce Tiffany.